Okay, welcome back. So we're going to continue talking about our test prep here. Go. And the next question we have here is we have the tangent of kx. We have find k so that this is continuous. So f of x equals the tangent of kx over x. Okay, when x is less than 0. Okay, and 3x plus 2k squared when x is greater than 0. Okay, so we have to find k so that this is continuous. So find k, not 0k, such that f is continuous. F is continuous. Okay, so what we're going to do is we're going to take a limit as x gets close to 0 from the less than side. Okay, so we're just going to go through and do that. So here we are. We have limit as x goes to 0 of tangent kx all over x. Okay, and we'll deal with this. So this is going to be sine of kx over x times 1 over cosine of kx. And what we're going to have to do here is we're going to have to multiply a top and a bottom by k. Okay, and this sine kx here and kx on the bottom, as x goes to 0, this limit here, that's going to be 1. So this is going to be equal to k times 1, we've taken the limit, times, hey, what's cosine as k goes to, or as x goes to 0? Well, if x is 0, k times x is also 0. Cosine of 1 is 1. So this limit from the left, okay, so this limit f of x goes to 0, of f of x, okay, for this part is equal to k. And now we have to look at what's going on with the right. X is a little bit bigger than 0 now. So let's go ahead and take a look at that. So we're going to have limit as x approaches 0 from the top. Okay, it's actually down there. So we have 3 times 0, just direct substitution, plus 2k squared. What would you like that to be equal to? Well, we'd like them to match up. So we'd like this to be k. 0, that's not too bad. Okay, that's 0. So we have 2k squared equals k. And we just have to solve that. So we're going to have 2k squared minus k equals 0. We could factor a k out, so we have k factored out. We have 2k minus 1, because the k's factored that out, equals 0. So either k equals 0, oh, but that wasn't allowed, so that's not a solution. Okay, or solving this part, we have k equals 1/2. So the answer to number 3 here is that this function is continuous when k is equal to 1/2. All right. So let's see here. Turn the page. Okay, that was number 4, I think. Number 5. Okay, we had find the derivative if f of x is equal to 1 over x squared using the definition. Okay. Now, I know what you guys are thinking, because I thought it too. It's like, well, why did we go through learning all these fancy techniques for taking derivatives if they're going to keep making us use the definition? And the reason why we do that is because through all your academic life, Calc 1, Calc 2, Calc 3, physics, differential equations, all of your engineering programs, you get problems that look what we would call analytic. They're polynomial functions, exponential functions, something, and you have to take derivatives of them. When you have your first real job, you're not going to get functions that are analytic. You're going to get, a scatter plot, and you're going to have values for these scatter plots, and they're going to say find the rate of change between 0.1 and 0.2, and you say, well, Here's the rate of change here. Here's the rate of change here. So we would have to look at these derivatives. But there's no analytic function for you to take a derivative of. You have to figure out the slope of this line over here, the slope of that line over there. Okay, so we use the definition of the derivative to help us prepare for the fact that you're going to be doing, like, all your math is going to be done by spreadsheet and once you finish your degree. Okay, so that's why it's there. And we want you to remember this lesson. So of course it's as painful as possible. So that way we all remember it. All right, so here we go. We define limit as h goes to 0. Okay, and you have to use this, okay? And what we have is f of x plus h minus f of x all over h, and we'll see what happens here. So we have, is that on my screen or is that you? That's you. Break out. All right, so we have 1 over h times 1 over x plus h squared minus 1 over x squared. I always move the 1 over h because, especially if it's a fraction, because I don't want to write fractions over fractions over fractions. It's just not a fun thing. So we've got two fractions with two different denominators. How do you suppose we add them? Get common denominators, you might say. Good. So let's get common denominators. We have 1 over h times, we have x squared, and we have x squared, x plus h squared, minus, we're getting a common denominator, so we have x plus h, all quantity squared here, all divided by what? X squared and x plus h squared. Okay, put the parentheses here. We can take limit as h goes to 0. I'm not going to be that picky about it. I would prefer that you at least paid some lip service to carrying out this limit until we took it. But you know, if this is the thing you're worried about keeping you from an A, then you're worried about the wrong thing. Okay, so try to remember to drop a limit in there once in a while. We'll both be happy. If you completely ignore it, I might have to dock you a little bit. Other calculus teachers, they take a lot off for not doing that. Okay, so at least remember to drop a limit in there once in a while. Doesn't have to be every step, it doesn't have to be every line, but once in a while, remember to do that. We got common denominators. Let's go ahead and say we add the common denominators. We have x squared minus, well, I have to FOIL this out. Can I do that quickly for us? Can I just say this is x squared plus 2xh plus h squared? Yep. All divided by x squared, x plus h squared. Okay, distribute the negative sign, that's important. So we have our limit as h goes to 0. Okay, and here we have on the top, we have x squared minus x squared minus 2xh minus h squared, all divided by, oh, there's a 1 over h out here too. Don't let me forget that. Okay, all divided by x squared, x plus h squared. Okay, let's clean up the top here. So we have limit, h goes to 0. Okay, x squared minus x squared, well, that's 0. So we have 1 over h here. We have negative 2xh minus h squared. And then we have x squared, x plus h squared. Well, at this point, there's an h common to both terms in the top. Why don't we factor that out? So we're going to have limit, h goes to 0. We have 1 over h. Now, I like to do it this way. H negative 2x minus h, just because I often teach pre-calculus, and a lot of times people forget. They just start canceling h's without really being careful about it. So I try to be careful about it just to show people, hey, this is what you're supposed to do. Okay, we have that. Oh, now we can cancel the h's. Make sure you cancel them correctly. Okay, the problem is over The problem is almost solved once you cancel this h. Okay, now it's safe to take a limit. So let's go ahead and do that. So we have limit as h goes to 0. It's going to be the last time we write limit for this problem. Look, we have negative 2x minus h, okay, all over x squared times x plus h quantity squared. Now let's go ahead and take that limit, direct substitution, because there's nothing that's going to be a problem here, that we're not going to be divided by 0, and we end up with minus 2x. Okay, the minus h disappeared because we went to 0. We have x squared, and then we just have x plus some stuff squared. Okay, but that went away. One of the x's is going to cancel. We have x squared times x, and we end up with minus 2 over x cubed. And that is our definition, or that is our derivative by the definition. Okay, so it's important to be able to do that, because again, when you finish the engineering life and you go off to do different things, you're going to have to take derivatives, but it's going to be spreadsheet derivatives. Okay, let's see. The last problem I wanted to do here is y is equal to x to the 1/4. Actually, it didn't say that. It started with the 4th root of x. The first thing I would do is change that to a calculus problem rather than an algebra problem. This is an algebra problem. Okay, minus 3e squared. Okay, so this is equal to x to the 1/4 minus 3e squared. Okay, that's equal to y. Go ahead and take the derivative. So we use our power rule here. That's simply 1/4 x, 1 minus 1/4, right? If I have $1, or if I have a quarter and I have to pay somebody $1, I am now in debt 3/4. And then 2e squared, see, that's just a constant. So that's not going to be, that's going to be 0 in our derivative. So at that point, you say, hooray, you're done. Okay, so that's problem number 3. So thank you for coming by tonight, and I hope that was helpful. And yeah, good luck with the test.